for more than 39,000 years, beneath the icy tundra of Siberia, an ancient giant lay, hidden frozen in time, preserved by nature's cold hand. The woolly mammoth, once the ruler of the Ice Age, is no longer just a fossil in a museum. Scientists have unearthed remains so intact, complete with flesh, fur, and even blood, that they may hold the key to resurrecting this long-lost species. What does this discovery mean for humanity, for science, and for the future of our planet? In 2013, on the remote Lyakhovsky Islands off Siberia, Russian scientists stumbled upon a find that shocked the world: the frozen remains of a female woolly mammoth estimated to be 39,000 years old. Unlike the dry bones or fragmented tusks usually recovered, this specimen was remarkably preserved. Its reddish-brown hair still clung to its skin, its muscle tissue was intact, and most astonishingly, when scientists pierced the body, dark blood oozed out. The permafrost had locked this animal in a natural freezer for millennia. For the first time, humanity could see what it was truly like to stand face to face with a creature from the Ice Age, not as a skeleton, but as a nearly living body. Scientists immediately began to ask, could this mammoth's DNA bring the species back to life? The woolly mammoth is closely related to the modern Asian elephant, sharing over 99% of its genetic code. With DNA samples extracted from the preserved tissue, researchers began to map out its genome. The mammoth's blood and soft tissue offered clues not only about the creature itself, but also about its incredible adaptations: antifreeze-like proteins that kept its blood flowing in freezing climates, and dense layers of fur that shielded it from the Arctic winds. But the discovery went beyond curiosity. If the DNA was viable, scientists could potentially insert mammoth genes into the embryo of an Asian elephant. The concept of de-extinction moved from science fiction into the realm of scientific possibility. But just because we can, should we? That question split the scientific community. Some argued that reviving the woolly mammoth could restore balance to Arctic ecosystems. Mammoths once trampled snow and grazed vegetation, maintaining grasslands that helped lock carbon in the soil. Without them, tundra landscapes became dominated by moss, releasing greenhouse gases. Bringing mammoths back could help fight climate change. Others warned of the risks. Introducing a long-extinct species could disrupt modern ecosystems. Asian elephants used as surrogates may suffer. And most importantly, are we playing God by reversing extinction? Still, the allure of resurrecting a creature that last walked the earth tens of thousands of years ago was too powerful to ignore. Scientists at Harvard University, led by geneticist George Church, began working on the ambitious project of bringing the woolly mammoth back to life. Their method wasn't to clone the mammoth outright, but to edit the genome of the Asian elephant using CRISPR technology. By inserting mammoth genes that control traits like thick fur, fat storage, and hemoglobin adaptation to cold, they aim to create a hybrid, part elephant, part mammoth, what some call the mammophant. This new creature wouldn't be an exact replica of the woolly mammoth, but it would be close enough to survive in icy climates and potentially perform the same ecological role. The dream of seeing herds of mammoths once again roam the tundra became more tangible. Meanwhile, Siberia's permafrost continues to reveal secrets. Dozens of mammoths have been unearthed in the last century, but the 39,000-year-old discovery remains one of the most astonishing due to its state of preservation. Scientists stored samples of its tissue, blood and hair in cryogenic facilities, ensuring they remain intact for future study. To researchers, this mammoth is not merely a relic but a time capsule, a frozen message from Earth's past. By analyzing its stomach contents, they learned about Ice Age vegetation. By studying its teeth, they uncovered migration patterns. Every detail added a piece to the puzzle of how mammoths lived and why they disappeared. The extinction of the woolly mammoth was not sudden. Around 10,000 years ago, most mammoths vanished due to a combination of climate warming and human hunting. A small population survived on Wrangel Island until about 4,000 years ago, when the pyramids of Egypt were already standing. This fact alone raises haunting questions. If humans played a role in driving them to extinction, do we now bear the responsibility of bringing them back? And if we succeed, will we also learn to prevent the same fate for modern species like the elephant, the tiger, or the polar bear? Today, companies like Colossal Biosciences in the United States have raised millions of dollars to make Mammoth Resurrection a reality. Their goal is not simply to create a zoo attraction, but to rewild parts of Siberia with mammoth-like creatures within the next decade. The vision is bold: vast grasslands restored, carbon emissions reduced, and ecosystems revitalized. If successful, the project could set a precedent for using genetic engineering to revive other extinct species from the passenger pigeon to the Tasmanian tiger. What if we could rewrite the ending of the woolly mammoth, a creature whose ancestors roamed the earth as far back as 5 million years ago? The oldest known mammoth, the steppe mammoth, lived during the Pliocene epoch, which ended around 2.6 million years ago. Over the next few million years, mammoths spread across Eurasia and North America. Some grew into the woolly mammoths we know today, adapted to survive in the coldest climates. Others, like the Columbian mammoth, thrived in warmer regions. These mammoths reached up to 12 feet tall and weighed 12 tons. They were the largest land mammals in North America until their extinction around 10,000 years ago. The rise of the woolly mammoth is a testament to evolution's power. As temperatures drop during the Pleistocene epoch, mammoths develop thicker fur, a layer of fat under the skin, and smaller ears and tails to conserve heat. They also had shorter, stouter legs for stability in deep snow and larger brains compared to modern elephants. These adaptations allowed them to dominate the icy landscapes of the north, where they remained the top predator for tens of thousands of years. Woolly mammoths fed primarily on grasses and sedges, which they cut using their large, curved tusks. These tusks could grow up to 16 feet long, making them the largest teeth of any mammal. The tusks were not just weapons against predators, but tools for digging through snow to reach food, scraping bark off trees, and even for attracting mates. The woolly mammoth was also a highly social animal, living in herds led by the oldest and most experienced females. They communicated using a variety of sounds, including trumpets, rumbles, and screams. But the story of the woolly mammoth is not just about adaptation and survival. It is also a story of extinction caused by both environmental and human factors. As the climate warmed at the end of the Ice Age, the woolly mammoth faced a changing world. Their thick fur and fat layers, once advantageous in cold climates, may have become burdensome in warmer temperatures. Additionally, rising temperatures led to the melting of the Arctic ice, which in turn caused rising sea levels. This, in turn, transformed coastal habitats and disrupted migration patterns, affecting the availability of food resources for the woolly mammoths. Furthermore, the woolly mammoth was hunted by humans for its meat, hide, and ivory tusks. As humans migrated into mammoth territory, competition for resources increased. Humans, with their advanced hunting techniques and ability to adapt to changing environments, gradually outcompeted the woolly mammoth for food and space. The last known population of woolly mammoths survived on Wrangel Island in the Arctic Ocean. However, around 4,000 years ago, the island's vegetation changed from grassy woodlands to shrubby tundra, likely due to increasing dryness. This shift may have resulted in a loss of habitat and food resources, contributing to the final decline of the woolly mammoths. And then they were gone. Today, we marvel at the discovery of the 39,000-year-old woolly mammoth in Siberia. It serves as a reminder of the incredible animals that once roamed our planet and the forces that shaped their existence. By studying the preserved remains of the woolly mammoths, scientists hope to unlock further secrets about their biology, behavior, and the environment in which they lived. The knowledge gained from these studies not only helps us understand the past, but also informs our efforts to protect the biodiversity of the present and preserve it for future generations. Now it's your turn. What do you think about the de-extinction of the woolly mammoth? Let me know in the comments below. And if you want to support my work, consider becoming a patron where you can watch episodes before they are released to the public. Thanks for watching. See you next time.